Hello everybody and welcome back to the Fusion 360 for FTC series. This is the 16th video in the series. If you watched the previous 15 videos, I recommend you do so by clicking on the card in the corner. In the previous videos, we've only been working with creating and modifying bodies. In this video, we're going to be looking at how we can combine multiple files into one file to create an assembly of parts. And we're also going to be looking at components, which are the base for joints. So components, unlike bodies, they cannot be modified. Their geometry is solidified, and there are a few ways to create a component. So under here in the drop down, you can create a new component. You can use multiple bodies, or you can use one body. It's pretty easy. But the reason that you might want to create a component is so that you can use the joints, as they can only be used with components, not bodies. So I've created this file here and I've saved it, and it's just called joint example. And the reason that I've created this empty file to work with is that you can only add files into another file if it's been saved. So I've created these three files here for today's tutorial. And the way that I bring these in to this file here is I right click on them and I do insert into current design. And it gives me some options about where I want to place it. I'm just going to leave it at the origin for now. And I'm going to click OK. And now you'll notice that we have a component here. It's not under the bodies drop down or anything. But if we opened up this file, you would notice that this is a body in fact. So when you save a file and you insert it into another file, it automatically becomes a body. If I change this body here, if I made it taller or shorter or something, there would be a way to update it in this example. And we'll be getting more into how to manage components and sub-assemblies in the assembly tutorials. But for now, let's just stick with this. So the next thing I'm going to insert is this joint component part 2, and I'm just going to drag that out so we can see it just like that. And now let's talk a little bit about what are joints is. You may be familiar or you may not be familiar with the concept of joints. So basically, when you're creating a robot, for example, you need everything to stick together on the assembly. You need all the parts to be together in a realistic fashion, and that's not always just make them rigidly connected together. Sometimes you want movements, sometimes you want it to rotate, sometimes you want it to slide, and this is a way of creating those realistic interactions between different components. And it's a really important way to visualize your robot when you're CADing it. Like, how is this going to rotate? Is this going to interfere with anything when it rotates? All you do is create a joint, rotate it, and see if it interferes. So we're going to be looking at 4 joint tools today. We're going to be looking at the joint, the as-built joint, the rigid group, and the ground, which is not in this menu, but it's inherently tied into two joints. So I'm actually going to start with ground, and what ground does is basically locks a component's position and rotation. And so this can be important. For this, I want my cylinder to be locked in place, and this is going to be our moving piece. So we can pretend as this is maybe welded down onto the ground or something. So the way that you do that is you can double click to select the component, and you can right click and you can press ground here. And then you'll notice it has this little pin icon here. You can also right click here, and if I just clicked unground, it would be ungrounded again. So if I ground it and I tried to move it with the move tool, you'd notice that if I put this on components, I couldn't select this one, but it would let me select this one. If I ungrounded this, I could select it and move it. So that's it for the ground. It's really simple. Just ground. You should really only ground one part in the assembly if everything's connected. Just ground the piece that makes the most sense if you need it. Let's start off with joint. So I'm just going to do the joint tool right here. The command is J, and it's here, up here, and it's down here. So the first thing that it asks for is it asks for the component 1, and the component 1 is going to be the one that's moving. So you always have to remember component 2 is the rigid one, and component 1 is the one that's moving. So I'm going to select, when you hover over this you can see some points, and these are just points of selection. I'm going to select here, and you'll notice that it's snapped there with the yellow sort of circle thing to the center, and that's right where we want it. It's the center of the circle. Now we can select a point to snap to here. Again, I'm going to select the center of this circle, and now you'll notice it's brought it over and it's doing some sort of shaking animation sort of thing. So let's take a look. There's a lot of stuff here. It's really not that complicated. These options here, the simple mode is just the one I use the most to select components and where to align them, but sometimes it can be useful to use the between two faces and two edge intersection tool. This is pretty easy, especially in their picture here. You can see that they have a sort of filleted part, and if you want to align the corners of a filleted part with a non-filleted part, for example, you wouldn't be able to select it there, but if you use the two edge intersection tool, you would be able to. And you'd be able to select the edges that define the fillet, and then it would give you the point in the corner. But really, the simple is mostly what you need in FTC, as the selections are quite simple and the geometry isn't too complicated. So the first thing that we're going to look at is the joint alignment tool. So we have some options here. So flipping it, we'll flip it over the XZ axis, which we defined on our point. So our point that we are snapping to is on the XZ axis, so it's flipping it over just like that. You can see it goes down and it goes up. So it's important to making sure that your piece is on the right side. I'm going to have mine down below like this. Then we just got some angle, and this adjusts the angle around the point that you're snapping to. Just like that, you can change the angle. So if I want mine at 45, I put it at 45. And then the offset X, Y, and Z allows you to offset the part. And now it looks like these two wouldn't be connected. They wouldn't be connected, but in fact, we still have a rigid connection between them, even though we've offset it. So I'm just going to put this back at 0 and 0, and we have it back there. So let's take a look. When we first animated that, it gave some sort of some shaking thing, and that's because we have the rigid joint selected, and this means that there's a rigid connection between these two components. You can always just click here in the animate to preview how the joint is going to work. When you're using a joint tool, you select the type of joint by clicking on these options down here. That's basically it. So we're starting with the rigid. By default, it's rigid, and we've just got a rigid connection between these two joints. So if I click OK, you'd notice a few things that would happen. One, we've got this sort of white and blue puzzle piece thing here, and we got another drop down over here. So I'm going to unground this for now, and we're going to take a look at what happens if I move the cylinder here. And what the joint has done, you'll notice that it's moving together and it's staying at that point. And because we've used a rigid joint, the position and angle is now locked in. So if I rotated it, you'd notice that both the cylinder and the little X thing are rotating together. So that's what the rigid joint is done. We've defined a rigid connection at the points that we specified and at the position and angle we've specified, just like that. And you can hide the joints by just clicking here, and you can also look in the drop down here to find the joints individually and hide them. Next, let's take a look at the revolute joint, and I'm going to add some more components in to use for this one. We don't want them to be on top of each other, so I'm just going to move them over just like this. And you're going to be doing this a lot if you have robot assemblies, is just getting your pieces in together with the insert component. Same thing. I'm going to select joint or press J. I'm going to select the center of this, the center of this. And instead of doing the rigid with the shaking, I'm going to go to motion. I'm going to change this to revolute. And we have an option here. So right now it's rotating around the Z axis, just like that. And there are some things that we could change about this. We could change the rotation. So now it's rotating like this. And now we also have this axis. You can also use a custom axis, and this you would have to select an axis to use for the rotation. So if I selected this, for example, you'd notice it would be rotating around that, and it's kind of like moving up and down. And that's because the axis isn't going straight through. And you may have noticed, like, why when I select Z, it's rotating like this, but the Z-axis is facing this way. Isn't this the Y-axis? If we look from the top, isn't this the Y-axis? And that's because this is for the part, which is the Z, X, and Y for the individual part. So just like that. You can use custom axis, constructor axis. We learned about how to do that. And that's the revolute joint. Again, you can do the offsets and it still works, just like this. If I went to motion and animated it, now we're rotating around like this. It's not rotating in place off to the side here. So you can just use the offset tools and get the rotation correct. If there's no offset, it's going to be rotating the part and it's not going to be orbiting at all. So I'm just going to put this back on 0 and 0, just like that. And we click OK, and now we have our revolute joint. And so let's say you wanted to preview this joint motion again. There's some ways that you could do it. So if I right click here and I click drive joints, I can actually specify the angle for this joint to be driven, and that will change it in the model. So if I went -80, it would actually change it just like that. If I went Control Z, it would snap it back. That's one way to see the joint working. If we did animate joint, you would see it rotating, and if you did animate model, you could also see it rotating. And the difference between animate joint and animate model is the animate joint only shows the movement for that joint. If I had something rigidly connected on top, the animate joint would just show this thing rotating around. If I did animate model, it would include all the joints in the model and how they interact. Next, let's take a look at the slider joint. So I'm going to bring in some new pieces, bring them over just like that, and bring in our part 2, bring it over just like that. I'm going to hit J for joint, and I'm going to select the center of this piece as the piece that's going to be jointed, and this piece here as the defining for the joint. So it's still on rotate or revolute, so I'm going to change it to slider here. And what the slider does is it moves it up and down along an axis. So we can change the axis here for it to move along. If we selected X, it would move this way. If we selected Y, it would move front and back like that. And again, you can use a custom axis for it to slide along. But I'm just going to keep it on the Z right now. I'm going to have it sliding up and down this cylinder. Again, we have our same tools for the offset and the angle and the flip. Flip, we know how the angle works. If we do the offset, nothing strange is going to happen here. It's just going to move up and down to the left and the right, or the front and the back, however you do it, just like that. And we can bring it back to 0, because I want it sliding up and down this cylinder. And I'm going to click OK. And now we have our slider joint. And you may have noticed that each joint has its own special symbol that you can see. So you should get familiar with those symbols so you can quickly see which joints are where on a assembly. So the sort of puzzle piece is a rigid one. The flag is a revolute, and the down arrow with the white bars on either side is a slider. Next, let's take a look at the cylindrical joint. I'm going to bring in some more pieces here to work with, just like that. This can also often be a monotonous process, bringing in all the pieces to work with, as it's quite slow and you have to go through the menu and find where you've saved all your pieces. So again, J for joint, or click there, and I'm going to select this and this as always. And for the motion, I'm going to change this to cylindrical. And now what you'll notice is that this is our first sort of combination joint, which is, it's really just a revolute and a slider combined. And you can see that by the symbol here. You've got the slider sort of white lines with the arrow pointing down, and the revolute flag. And we can see for this one that the axis, there's only one axis that you can choose. So this means that the axis of rotation and the axis of sliding is the same. And that's what it is for the cylindrical joint. The pin slot, which we'll be looking at next, these are different. So if I change this to Y, it would move along the Y and it would rotate along the Y. Again, we have our X, Y, and Z and custom. I'm going to leave this right there, and we have it like that. Now, if I offset it, we can take a look at how the joint behaves. And what you'll notice is that if we look from the side, we can see that it's sliding up and down. And we've got that sort of orbiting, rotating movement going on. So you can sort of, whenever you're offsetting a revolute joint from the center point, you can sort of think of this as like a planet rotating around a star or something. Something like that. So I'm going to stop that, and I'm going to bring it back to 0 in the middle, just like that. And now we have a few more joints to look at. I'm going to bring in my parts again, just like this. Slide them over. And let's take a look at the pin slot joint. This one's similar to the cylindrical joint, except for that the axis of rotation and the axis of sliding is different. But again, it's a combination of the rotate and the slider. So if we hop over here into pin slot, what you'll notice is now we have our two different axis selection menus here. And since this one is on Z, the rotate is on Z, it will not let me choose Z here. And this is because you basically can't make the pin slot behave like a cylindrical joint. The axis has to be different from the rotate and the slide on the pin slot, and it has to be the same on the cylindrical. So it's something to remember. If you're ever like, why can't I select the Z here? It's because you're in pin slot, not cylindrical. So if we take a look at what will happen if we are sliding on the X and rotating on the Z, it's about as you'd expect. We're just moving left and right and going like that. So what I want mine to do is I want mine to go up and down and rotate sort of like sideways. So I'm going to choose for the rotating, I'm going to choose X, and the sliding just like that on Z. And if we preview that, you can see that it's moving up and down, and it's rotating like this. It's a pretty complicated joint with the varying axes. Again, we have our offset tools. We know how all of that works. And I'm just going to click OK, and now we have all of this. So the next joints that we're going to be looking at are the planar joint and the ball joint, and these are pretty complicated, and I don't think I've ever used them in an FTC robot, but it's good to know how they work. Especially the ball joint is really complicated. So I'm going to bring in this, and this is going to be the base for our planar joint, and then this, as always, is our moving part, just like that. And I'm going to hit J for joint and select the center of this, and I'm just going to put it at the center right here. It's snapping to the center, and we can go to motion and choose planar, and I'm going to flip this over so it's on top. And now it's important to preview the motion so you have it correct. So what it wants us to do is select the axis normal to the plane. So this is not the x-axis. If we change this to the one that's correct, which is the z-axis as our normal, then you can see that it's sliding along this plane just like this. And there's some options you can have here. You'll notice that it's actually these numbers here. It's sliding in the x and the y simultaneously, and it's also rotating. So we could change this to custom, but this is how it is for now. This one's pretty complicated. I feel like I don't know what you would use this for on an FTC robot, as you don't often have this sort of thing where it's moving in both the X and the Y and it's rotating. But it's good to know anyways. So I'm going to click OK, and if we animated this joint, you could see that movement just like that. And you can press escape to end this at any time. The last one that we're going to be looking at is the ball joint. So I'm going to go ahead and bring this back in. And the idea for the ball joint is that it's sort of like 3 revolutes combined into one on the same point. And the planar was 2 sliders and 1 revolute. Or you could think about it as a pin slot and a slider. So I'm going to hit joint, select our pieces just like this, and for the motion I'm going to change this to ball, and now you can see we've sort of got this like gimbal action going on, where it's moving in all 3 at once, and we can change which one is the pitch and which one is the yaw here, so we can select custom axes for these, but it already knows that X and Z is the correct for our setup here. We could do some offset here and take a look at what that's going to be like. And again, we're going to have our sort of like orbiting action going on here. So it gets pretty complicated here to visualize how this is going to work inside, like without actually seeing it. Once you start doing offsets with like the ball joint, just like that. So I'm going to put everything back on 0, and it's just going to sort of like rotate around this center point here, and just like that. And this could be some sort of joint that can move in all directions, like a ball joint. And I click OK, and this is you can see the thing here is 3 revolutes. That's the symbol. In the planar, we've got like a sort of like pin slot and a revolute. So that's our 6 joint types that we've taken a look at. Next, we're going to take a look at briefly the as-built joint and the rigid group, and then we're going to call that the video for today. So the as-built joints, what you may have noticed with these joints is that when we select the point for the points to like our jointed part to our receiving part, it moves the piece into place. It was moving this X piece into place every time. With the as-built joint, that's not the case, and what it actually assumes is that you've already aligned everything in place how you want it to be. So I'm going to bring in some more parts here to work with. We're not going to look at all the joints in the as-built joint, as they are the same as the other joints. We're just going to take a look at how do you use the as-built joint. So if I want to joint this with this, I would just use joint. But if I looked in as-built joint, which is Shift J, by the way, all it's asking for is some components. It's not asking for a position on those components, and that's because it assumes that you've already had it already aligned. So if this is where I want these components to be rigid grouped, if they are rigidly connected here, then I would just select these joints, and what you would notice is that it's rigid grouped them, and we don't have any options here like offset or angle or anything. It's already assumed that you've aligned it the way that you wanted to. So, well, let's take a look at how do I align this. There's a tool that we haven't looked at before, and it's the align tool. And basically, you just select a point on the first one you select is the moving one. The second one you select is the one that's going to remain stationary. You select it just like the joints. Just go like this. Go like this. You have the flip option and some angle and stuff. So if I moved it just like this, now we would have it aligned. And now I could use the as-built joint and use, if I want to do revolute just like this, then the last thing I would have to select, I selected my components, is just the position to revolve around. And just like that, now we would have it revolving around this. There are some situations where you need the as-built joint, or it's easier to use the as-built joint than the normal joints, but I do recommend that you use the normal joints as much as possible, because the as-built joint sometimes doesn't update correctly. If I change this part, the align tool might not have worked properly, so when the as-built joint, it'll be in the wrong place. Whereas the joint tool, it's always based around this geometry. So I selected this top point here. If I made this top point taller, it would update properly. And so I recommend that you use the normal joints as much as possible. But there are definitely situations where you need the as-built joint. So that's it for the as-built joint. You just select your components, and then it asks for point of rotation, point of axis of sliding, whatever it needs. So pretty simple. You're just not defining position or angle or anything with the offset tools that we were looking at before. And the last thing that we're going to work with is the rigid group. And this one, it's really tempting to use when you're just creating a robot. Basically, you're just connecting a bunch of parts together. Not with a joint or anything, you're just making it together. So if I went like this, and I'm going to make like a sort of stack here of cylinders. I'm going to bring this one up just like this. So it's sort of we're going to have 3 stacked on top of each other. Bring this one up to 200. Now we have 3 stacked on top of each other, and I want these to be connected, rigidly connected. The rigid group tool allows you to make these their position relative to each other is fixed. So you just select as many components as you want. There's no other options. It's basically an as-built joint, as-built rigid joint, but between multiple pieces. So if I went OK, and then I did a move on this, you would notice that they would all move together. Now, um, this is really tempting to use when you're first creating a robot, is to, oh, I align all my pieces together and then I just rigid group them all together in one big rigid group. If I have 100 pieces that I want together, I just use the rigid group. But that's not good practice when you're creating a robot, and that's because the rigid group does not join geometry. If I went back and I changed this piece, this would all be messed up. So it seems like it saves you a lot of work using either the asbuilt joint. I could have used the asbuilt joint between this one and this one, and this one and this one, or I could have just brought them in and then jointed them properly. But it really can create a lot more work down the line. So I highly recommend that you stay away from rigid groups as much as possible. It can be useful though. For example, if you're bringing a component in, if you're inserting a component like this cylinder, but instead of just being one part, it has a bunch of parts, and you just want to put it together so you can see how it aligns, and then you're going to go back and put the joints in the sub-assembly that you inserted, that can be a good use, just to get everything so you can move it together and align it together. But that's the rigid group tool. And that's all for today's video. We covered a lot of ground today, how to use these joints. So when you're just using one of these joints, if you want to create a joint, you just pick the one that reflects how that is going to perform in real life. And it's honestly pretty easy to decide how it's going to work. Like a gear, it rotates with an axle. So I'm going to rigid join it to the axle, and then the axle is going to be driven by the motor, so it's going to revolve with the motor shaft. Pretty easy stuff like that. It's pretty easy on FTC robots just to think about how everything is going to work. There are some instances where it's harder, like linkages or sliders. It can be often hard. So in the next video, we're going to take a look at the remaining joint tools. So we're going to be taking a look at the contact sets. We're not going to be taking a look at the motion study for kinematic motion analysis, as this is just way too complicated for FTC, and it's not really necessary at all. You're not going to have kinematic motion in FTC, so we're going to skip that. We're also going to take a look at, you may have noticed the thing is going outside the cylinder in some of these. It's like going in the sliders, it's like going above, or it's going too far below. So we're going to be looking at how to you edit the joint limits so it doesn't go too far. And then after we've done that, after we've looked at the contact sets and the motion link, we're going to be putting the joints on our screw and nut. So that's going to be very exciting. I hope you learned something in this video, and I'll see you in the next video.